Hello and welcome. Today we're going to talk about one of the most mysterious and fascinating objects in the universe, black holes. We know that they are incredibly dense and have incredibly strong gravitational fields, but what's inside a black hole? Let's find out. To understand what's inside a black hole, we need to start with the basics. Black holes are formed when massive stars collapse in on themselves, creating a singularity, a point of infinite density and gravity, surrounded by an event horizon, the point of no return. Once something crosses the event horizon, it is trapped by the black hole's gravitational pull and can never escape. But what happens to it once it's inside? One theory is that matter that falls into a black hole is crushed into a singularity, a point of infinite density and gravity where the laws of physics as we know them break down. At this point, we simply don't know what happens. Another theory is that matter that falls into a black hole is stretched into long, thin strands, a process known as spaghettification. This happens because the gravity near the singularity is so strong that it stretches objects into thin, elongated shapes. But what about information? Does it get destroyed when it falls into a black hole? This is a question that has puzzled scientists for decades, and one that is still being explored. Stephen Hawking proposed the idea that black holes radiate energy, a phenomenon now known as Hawking radiation. This radiation is thought to carry information about what fell into the black hole, suggesting that information may not be destroyed after all. Another fascinating idea is that black holes may be connected to other parts of the universe through wormholes. These are theoretical tunnels that allow matter to travel between distant points in space and time. If black holes are connected in this way, they could be a gateway to other parts of the universe. So, as we discussed earlier, black holes are incredibly dense objects that form when a massive star runs out of fuel and collapses in on itself. The gravitational pull of a black hole is so strong that nothing can escape it, not even light. This makes black holes incredibly difficult to study, as we can't directly observe them. However, scientists have been able to study black holes indirectly, by observing their effects on nearby matter. For example, when a star gets too close to a black hole, the intense gravitational pull can cause the star to be ripped apart, creating a bright burst of radiation that we can detect. But what happens to the matter that falls into a black hole? Well, according to our current understanding of physics, the matter is crushed down into an infinitely small point at the center of the black hole, known as the singularity. This point is surrounded by a region known as the event horizon, which marks the boundary beyond which nothing can escape the gravitational pull of the black hole. Inside the event horizon, the gravitational pull becomes so strong that it warps the fabric of space and time. This effect, known as space-time curvature, causes time to slow down and space to become distorted. In fact, the closer you get to the singularity, the more extreme the space-time curvature becomes. At the singularity itself, space-time becomes infinitely curved, and our current laws of physics break down. So, in a sense, we don't really know what's inside a black hole. Our current understanding of physics can't explain what happens at the singularity, and so we're left with a mystery. Some scientists have proposed alternative theories, such as the idea that black holes might be doorways to other universes, or that they might contain exotic forms of matter that we don't yet understand. Of course, these theories are still highly speculative, and we have no way of directly testing them. For now, the study of black holes remains one of the most exciting and challenging areas of astrophysics, and scientists continue to push the boundaries of our knowledge in this field. In conclusion, black holes are some of the most fascinating and mysterious objects in the universe. They are invisible to the naked eye, but their presence can be detected through their effects on nearby matter. As matter falls into a black hole, it becomes compressed to an infinite density and the laws of physics as we know them break down. While we still have much to learn about black holes, recent observations and research have given us some incredible insights into these enigmatic objects. With the help of advanced technology and new discoveries, we can continue to unravel the mysteries of the universe and better understand the incredible phenomena that lie within it.